In 2013, a low-budget movie came out called Begin Again. It told the story of Dan Mulligan, who was down in his luck A&R man, who stumbled into a bar in New York to drink away his regrets, only to discover that it was an open mic night. And on the stage, Greta James, somebody that he didn't know, a young woman, was up singing a song with her acoustic guitar. And something special happened in that moment. This is how the scene plays out.
So you find yourself at the subway with your world in a bag by your side, and all at once it seemed like a good way. You realize it's the end of the line. For what it's worth, here comes the train upon the track, and there goes the pain. It cuts to black. Are you ready for the last act? To take a step you can't take back. Taking all the punches you could take, took them all right on the chin. And now the camel's back is breaking again, again. For what it's worth, here comes the train upon the track, and there goes the pain. It cuts to black. Are you ready for the last act? To take a step you can't take back.
It's a great little movie. It's well worth watching if you haven't seen it already. But there's something that's happening in that bar that is quite interesting to me. Dan is having an experience that nobody else is having. Now, the director helps us to see and understand this by quite literally getting the instruments to play themselves. Because in that moment, Dan, alone in the room, is hearing what others can't. He can hear the full band. He can hear it all come together. And that's why he has an experience unlike anybody else in that room. Now, you might wonder why it is that we're talking about something like this whenever I should be talking about GIS, but the clue maybe is in that message on the screen. I wonder, are you ahead of me where we're going to go? We're not talking so much about hearing what others can't, but we're talking about being able to see what others can't. And that is the bold claim that Esri, the company that makes ArcGIS, for instance, makes. It enables you to see what others can't. In fact, Mark Enzer, the geography teacher from England, talks about this as being geography's superpower, our ability to see things that other people can't see. And it is amazing whenever we're sitting and looking at a landscape, just how much of that comes through. In fact, I think there should be a rule. I think there should be some kind of law that any time that a geography teacher gets on an airplane, that we should have automatic right to the window seat. I don't know if you're like me, if you don't end up getting the window seat and you see the person in the row in front of you get in at the window seat, and just before takeoff, or just after the plane's taken off, they close the blind. They close the blind. That lovely view, and they close the blind. Don't they know there are meanders out there to feast their eyes on? Don't they know there are even oxbow lakes for you to be able to look down and go, oh my goodness, look at what's down there? I think there should definitely be a rule that geography teachers should have the view out the window. Because when we look out the window, we see things that others can't. So I'm going to share with you now a photograph that I took out of an airplane window a couple of summers ago as I flew into Tenerife. Now, I want you here to have a look and see what you can see. I want you to notice what you see in that landscape. Others would just look out and see a beautiful island. But what are you seeing? You're seeing the topography, aren't you? The shape of the land. You're seeing those deeply incised V-shaped valleys. You're seeing how the drainage pattern has caused that significant erosion on the way down. You're seeing here to the top right, the cloud coming in. You're maybe making some assumptions about prevailing wind there, that perhaps the northern side of the islands get more cloud and rain than the southern. You're probably making some assumptions then about what the vegetation will be like. Down here to the bottom left, you're noticing the scale of this because you're seeing a little boat. You're getting a sense of just how big this island is, and follow that on up and you see some evidence of human settlements. You can see some green there, and far in the background you can actually see the airport, not the airport that you're going to land on, but the airport nonetheless. And what we can do whenever we look at a landscape like this as a geographer is to place conceptualized layers onto the landscape itself. We see what others can't. Peter Jackson, in a seminal and very important article in the Geography magazine in I think about 2007, said this: thinking geographically provides a language, a set of concepts and ideas that can help us see the connections between places and the scales that others frequently miss. That's why we should focus on geography's grammar as well as its endless vocabulary. Now, he was talking about the vocabulary being things like place names, but the grammar being the theories and the concepts. And that, he said, is the power of thinking geographically. We take these conceptualized layers and we place them onto the landscape. And I think that that is very much at the heart of what it means to think geographically. So how does this relate to GIS? Well, I think this sense of conceptual layers is very analogous to GIS, because what it does is turns the conceptual layers into literal layers. It's a way of managing and manipulating the vast array of information to turn the complexity into clarity through the use of those literal layers. So let's go using the power of GIS to that place that we've just been visiting. There is that very landscape looking out from the window of the plane, La Gomera. You can see the steep-sided valleys. You can see the drainage patterns. You can see the settlement. You can see the runway. But we don't just place metaphorical layers on here, conceptualized layers. We can literally turn on the layers. This is a volcanic island. Wouldn't it be interesting to see what the geology of it is like? That's no problem. We can turn on a layer. And we notice that there's a bit of a pattern here to the geology. I wonder what it's like when we go down here. Differences in the geology. I wonder how that relates to the settlement patterns there. Where are the settlements found? Or maybe it's better for us to zoom out to a different scale and see where the settlements are in totality here. And we can see that most of them are small settlements scattered around, but there is a large settlement here. Now, why is it over here? When we zoom out a little bit further, we see, oh, that's proximity to Tenerife. This is a small island. To be able to go from Tenerife across here, or from La Gomera to Tenerife, is a good thing, to use the services and so forth there. But let's come back into La Gomera a little bit more. Let's look in more specific detail about how these settlements are located around here. Is there a pattern to these settlements? Well, I wonder how they relate to the road network. This is a particularly challenging landscape here. The roads can't just go anywhere. There's particular places where they need to go, and we can absolutely see that there's a relationship between the roads and where the settlements are. In fact, if we zoom in a little bit closer, we're able to see that the roads are following up through the valley bottoms or zigzagging along the ridges, and that's where the settlements tend to be. So what we're able to do with the GIS is to take those conceptual layers that we have just been considering as we look out of the airplane, and we can turn them into literal layers, those layers and many, many more. And we can start to see that set of relationships and patterns that exist in this landscape that we were encouraged to look at. So why should we study GIS? I guess I would take a step back and ask a more fundamental question. Why do we study geography? And the answer, at least in part, is so that we can see the world better. So why GIS? Because that seeing better is enhanced by GIS. GIS enables us to do geography better, and that's why it matters. In a moment, we're going to go on to take a look at some examples of how we've been integrating GIS into the teaching of geography in Lurgan College. But just before we do that, I want to take a few moments to consider just a little bit of theoretical underpinning for the actions that we've been doing, because I think if we get our planning right, we're much more likely to get our implementation right. And I think that these three categories of knowledges that we're going to look at will help with that planning. The first of them is the know why. This is your pedagogical intent. Just like would be the case with any use of ICT and EdTech within your school, we start with the pedagogical question. What is it in terms of the geography that we want our students to know, understand, or be able to do? But very often what happens once we get that clear in our mind is that we move into the know-how, the procedural knowledge. Tell me how to do this. That's really not what I'm going to be focusing on here today, actually. I'm going to be covering a third category of knowledge that I would call know what. This is what I would categorize as functional knowledge. This is what you can reasonably expect the GIS to help you to do in terms of your pedagogical goals. Because I think it's the dialogue between the know why and the know what that really helps with the planning. And whenever you get that clear in your mind, if you know what it is that you can do, then there's always ways that you can find out the how, the procedural knowledge. So I'm going to be focusing more on the know why and the know what. It's kind of like this. Anytime you want to cook, particularly if, like me, you're not a particularly natural cook, you're going to need to follow through step by step. This is like your procedural knowledge, your know-how. But cookbooks are always very clever, of course, because just in case you get put off by there's far too many instructions there, they show you this picture, the know what is the end result going to be, and that motivates you to dig in to all of that know why, because you know this is coming. So it's the conversation between the know why and the know what that are really going to be focusing on here as we go in and take a look now at some of the examples of what we've been doing. So this is the first GIS task that we do with the Year 11s when they start their GCSE geography. We start with the topic, the Restless Earth, and look at earthquakes and volcanoes. So in this particular case, we're looking at the distribution of volcanoes around the world and how they relate to plate boundaries. Now, I will have covered this with them in class, so they'll have seen and discovered some things about the types of volcanoes, so your composite volcanoes, etc. And they'll know something about plate boundaries, but this is really allowing them to explore this in the map. So we can turn on the layer to show where the volcanoes are, and we can turn on the layer to show where the plate boundaries are. Now you can have a very simple task here. First of all, describe the relationship between where the volcanoes are and where the plate boundaries are. And you can see that most of the volcanoes are occurring on or near plate boundaries, but there are some in here where they're not. Now, you may say to yourself, fair enough, I can use that, use an atlas map for doing this. Why would I want to use this or do this using GIS? Well, it's because I think that the GIS map allows you to unlock some more powerful geography in this and to explore it in a little bit more detail. Let me show you how. So if we go to the volcanoes here, this software allows you to filter this, the data that's here. So I can go by type and I can choose composite. You can see the others that are there as well. The composite volcano, I can apply a filter and it shows me just where the composite volcanoes are and the different types of plate boundaries. So I can get them to explore the relationship between the type of plate boundary and where the composite volcanoes are. We're beginning to interact. Now, again, you might say, well, we could do that just using the key for the original one. So what value adding here? Well, the value that I think you're continuing to add with this is by being able to go in and explore some more of the details. So if I go in here to one particular type of composite volcano, we can zoom right into this one, and I can get them to zoom out again just to see where this is in context. Where are we in the world? They can zoom in and out, okay, and pop back in again to Mount Rainier. And what I can do is to get them to change the base map for this, and we can take a look at the imagery, the satellite imagery with this, and I can get them to test a little bit of a hypothesis. They will know that composite volcanoes are steeper but wider. So I can get them to click on here, and I can get them to get the height from this volcano. I can get them to go to the measure tool, and I can get them to measure the diameter of the volcano. They can record that information, and they're collecting some secondary data from the map. And then I can get them to contrast that with another type of volcano. So if we go here to the Shield volcano, which is in Hawaii, and again they can zoom out to see where in the world they are. We'll zoom right out with that one and straight back in again, or go to the bookmark just to take them back again. And there is the crater. Now you can definitely see that's a crater. It's definitely a volcano. But we need to come out and get a bit more of the size of this volcano. And they can use the measure tool here to measure the diameter of this volcano. And I'll just click that again. From here to here. And they can see that the diameter of the Shield volcano is much, much greater than that of the composite volcano. Now, having guided them through that, they can, of course, go and have a look at some other examples themselves. They can collect some more data. If we go to the overview here, they can go into some of these other places in North America where you'll have some of the composite volcanoes, and then go in and explore them and do the same kind of thing with a different volcano, a number of them sitting here in these mountain ranges. So really what you're allowing them to do is to have a chance not just to start with that very, very simple basic, there's a map of the world and there are the volcanoes. You're allowing them to explore this, to get a real sense of place within the world and to get a sense of what these volcanoes look like, so that they're not just little triangle symbols here, but they're actually physical features on the landscape. One of the core elements that is part and parcel of the teaching of geography is case studies. And part of the challenge we have with case studies is to turn space into place. Now, as I'm sure you'll know, place is space plus meaning plus sense of interpretation with it. And part of the challenge, I think, particularly if we take a look at the CCEA extreme weather event case study, you've only got to look at the impacts on people and impacts on people. This is Typhoon Haiyan in the Philippines, but I can write a statement like this in their notes. Most of the deaths occurred as a result of the unprecedented 6-meter storm surge that swept across the coastal plain up to 1 kilometre inland. Now, my students can sit down and learn that. They can repeat that in the exam, but what have they really learnt about this place? It's far too easy for a statement like that to be very, very decontextualised. So this is where GIS can come in. It's a way of really turning place or space into place for them. So this is their investigation of Typhoon Haiyan. We start with the overview just to let them see where it is in the world that you're getting these tropical storms, same storms, different names, different locations. Then we can come in a little bit closer to this one, and we can turn on the Typhoon Haiyan points. We can pull in some data, and I can get them to go in there and find out when it was that it started to become a typhoon category. They can get the categories from these. So they're beginning to get this sense of the typhoon coming in towards the Philippines. And then we can go in a little bit further again. We can come in here and I can turn on the satellite image, and they can get a sense of the size of that storm. And they can use the measure tools again. Here we are here, just go from there to there, get a sense of the size of that 1,700 kilometers across. But we can go in even further again, because what about that storm surge that we were talking about? If I turn on this layer of the storm surge damage and I turn on the legend, let me go to this one, storm surge damage, and turn on the legend, I can get them to explore the following hypothesis or the following idea. As distance from the center of the typhoon increases, the damage decreases, and they can use this key to get a little bit of a sense of that. We can go in further again to the island that was most particularly badly damaged by that, and then we can put on some more information about the storm surge here. These are symbols that show the height of the storm surge in meters, and again you could look at the relationship between distance from the center of the storm and the height of the storm surge, and you can click on here and get values. 3.6 meters here. Up here it's dropped down to 1.8 meters, definitely getting smaller. Up here it is 1.8 meters as well. But your eye will be drawn here, won't they? This one is 4.6 meters. So far away. How far away? Well, of course, they could always do the measure tool, couldn't they? So we're over 200 kilometers away, and the height of the storm surge there is 4.6 meters. Now, this is where the powerful geography can kick in. Because why? Why? What's going on there? And this is the power of the GIS, because you can unleash the ability to go and explore. Now, they might need a little bit of guidance in that one from you as a teacher, but surely part of your explanation could be that the shape here of this area, it's a bay shape, so as the waves are come across here, they are funneled in, and the height of the storm surge goes up at that point. But they are able to go and have a look and get a real sense of that. And then, of course, we can go into Tacloban city itself, which is mentioned in the case study. And I'll just turn off the storm surge. And the key here is showing you the buildings that are damaged and the collapsed. You can get them to look at the pattern there. You can get them to see where most of the red things are and where most of the yellow buildings are. You can get them to relate that to the height. There are the contour lines there. As height begins to increase and there's a valley coming through there, that ridge there isn't as badly affected. They can explore all of those things. And of course, this being a GIS map, I mean they can literally explore. They can go in and have a closer look at those things. But you can get them to go in really, really close to this area, and you can start to come down to a really fine-grained building by building analysis of what's going on. You can get them to measure tool again, and you discover that it's within that 100 meters of the coastline in particular. All of those buildings right next to it were destroyed. Now, when I designed this task, first of all, I used it with my year 13s, so I also use it with the year 11s. I got them to look at the distance from the shore and the damage or destroyed buildings. But one of my year 13 boys said to me, Mr. Hamill, I'm just noticing here that these buildings near the coast, is there something in relation to the building size and the damage that was caused? I hadn't even realised that or recognised or noticed that when I was designing the task. But unleashing them and giving them control of it enabled that powerful geography to come in for my students themselves to notice this. And we went on to Google Earth at that point, went and stood in this street here, Esparras Avenue, and we realised, of course, these are some more of your shantytown, the very, very vulnerable buildings. These buildings are bigger, more robust, and therefore they weren't being damaged as much, or they weren't being destroyed as much either. Badly damaged, yes, but not destroyed as much. But that was a real light bulb moment for me in terms of giving my students the freedom to explore this and to go from that really fine-grained all the way from that overview and to get that real sense of scale. Now, I did this exercise with them whenever they were in lockdown as well, and when they were learning from home, which is maybe a brave thing to do. You can ask me later in the questions about how exactly I designed that, but I managed to guide them through, and I got some feedback from the year 11s about how they got on. Some really interesting feedback here. In terms of the engagement, they really enjoyed it. Now, don't knock it. When they're sitting at home struggling with motivation during lockdown, for me to get feedback from my students, that was really fun. I loved the map work. But the engagement can't be the argument alone. There's got to be good geography from this, and they've also got to be able to do this. So what about that know-how? I did say I wouldn't talk much about this, but I suppose there's the know-how in two different categories or senses. There's the know-how in terms of how you would put together what I've just shown you that, and I'm not telling you today. I don't have the time, but the know-how of how to use it, which is an interesting know-how, because I was able to give this exercise to students during lockdown, and I'm getting statements like this. It was very easy to use, and it has been my experience that with a little bit of minimal guidance, the students can access this GIS technology and software really readily. The statement here, using the GIS at home was hard at first. Yeah, some of them find it a little bit more difficult, but with the support, look at what they've said. I soon got the hang of it. It was quite fun using the different tools to measure the area and the distance. But what about the powerful knowledge? I love these statements. It was good to see the path of the typhoon in real life map to get an idea of the extent of the damage it caused. I enjoyed measuring the areas of damage and the size of the typhoon because it allowed you to see how devastating these typhoons can be. It allowed you to see what they would otherwise not have seen. That compared to that. I enjoyed using the measuring tool because it put things into scale. Now, again, I can say here, 6 metre storm surge up to 1 kilometres inland. But does that really mean anything to them? Versus this, it put things into scale. And what about this one? I really liked using the GIS. The part I most enjoyed was getting to explore the map. It's giving the students the ability to own their own learning. There is not much ownership of learning in that. That is exam friendly. It gives them what they need for the exam, but that is not a good experience of geography. Look at this. To explore the map, because I think it was cool how we could explore the damage that happened and the place that it happened in. It's almost like I fed them the line. I promise I didn't. It was very interesting. Now, those are the students' words themselves. And to take that, to give the space a real sense of place through their ability to explore this GIS map. Another way that we can turn space into place is through another one of those core elements of geography, and that is fieldwork. Geography is a spatially contextualized subject. We don't just study rivers in general, we study particular rivers, and especially with the GCSE and AS specifications with CCEA, we get a chance to go out into the field and to collect some data, and very often it'll be in the form of some rivers fieldwork. So what role can GIS play in the fieldwork aspects of geography? ArcGIS has some other software called Survey 123, which is a data collection app that can be run off your phone and will allow you to collect primary data and, crucially, to geotag it. Now, the first time I heard about it was an event run by Esri Ireland up in Belfast introducing GIS. And as I sat in the event itself, this really fired off some ideas for me because, as I mentioned earlier on, I'm in charge of shared education. And as I discovered that there was this phone app that could geotag some pupil data, I thought to myself, now, I wonder could I get students from my school and our partner school to travel around the town of Lurgan and to do a survey with them about their perceptions of place. And I wonder could we explore what they think about that. And that for me was this dialogue going on here. I at that stage had no idea of the know-how. I didn't know how to make this work, but knowing what the software could do, knowing that it could do that, and knowing what I wanted to achieve, the know why fed me into the idea. And lo and behold, a few months later, having got some support and training from Esri, we had the students out and about doing this survey and went extremely well. In fact, we were incredibly honoured to be invited over to the Esri User Conference in July in 2019 in San Diego to be the first schools from outside of the United States of America to present at their user conference in front of 19,000 people about the work that we'd been doing using this GIS software in Lurgan. And we had 3 of our own students on the stage presenting there and doing us all incredibly proud. I could talk easily for all my time and more about all that we've achieved through that, but let me just show you a video of the day so that you can get a bit of a sense of the software in action. Lurgan itself is quite a divided town and has become more so even since the Good Friday Agreement and the peace process has begun. And very often the young people in the town don't actually just get an opportunity to meet. So the essence of the shared education programme is creating that opportunity.
In this particular project, it's been important to allow the children to see how they feel in different spaces in the town, right from the extremes of, what's traditionally a Protestant background or what's maybe a Catholic background towards the more shared spaces in the town, and allow them to see how they feel and how each other feels in those different spaces.
I'm feeling quite comfortable at the chapel here.
I'm feeling okay, I'm feeling grand, just it's afternoon time in a housing estate.
At 10 p.m. on Saturday night I would feel not really, feel uncomfortable with it.
I would say I do feel comfortable in my town, but I think that's just because I'm always in my area of the divide. I never really am in the other side of town.
There's not that many no-go areas in town.
I wouldn't consider any areas that I wouldn't go to in Lurgan. Maybe they would feel a little bit more uncomfortable around certain times of the year.
Places I wouldn't feel comfortable would probably be down the road in this housing estate down in Kilwilkie area. More of the IRA memorials and the murals and all that there. Wouldn't feel entirely safe there.
There's definitely a few that I wouldn't want to be at 10 o'clock on a Saturday night. I think park, I would never want to be there alone.
We hope to achieve with this project that the pupils will be able to see, as they went round today and they've taken the survey, that there is across the board a variation of how they feel at the different places, and to identify that it's okay that in certain parts some people may feel uncomfortable, but when they identify that, to actually start to make steps forward and going, right, how do we change this? How do we make a difference?
If I had to change anything, it would definitely have to be taking down flags.
I'd like my town to be more inclusive and everyone being able to tolerate each other.
What I would like to see in my town is a bit more unity. There is still a wee bit of a divide and it's just not needed.
It's been an eye-opener, really. Just seeing how people felt, where I felt comfortable and how they felt.
It's been very positive and it's good to hear different people's opinions on different places in town.
Enjoyed it. It's been fun. It's nice mixing with the other school.
I think it's just a good way to bond with people.
Being involved in this survey is all about creating that opportunity for them to have a different narrative when they're growing up, so that their experience growing up, even in a town, in a society that's still divided, is one where they are interacting, where they're meeting, where they're doing so from a young enough age that it forms their attitudes and experiences early on. When you give them that opportunity to meet, as we've seen today yet again, they just get on really, really well. And it's really just about creating those chances and then letting the young people do what they will do, which is just hang out and chat and make friends. The second example of fieldwork that I'll look at will be our good friend, the Colin River in Belfast. Well, I can't do a presentation about GIS and for geography in schools without mentioning rivers somewhere. Many of you, I'm sure, will actually use the Colin River for your GCSE fieldwork experience, or even if you don't, have used some of the others in Northern Ireland, this will give you a bit of a sense of how we can use this. Now, I use it as part of the planning. I'm not going to go into that in a huge part of detail today, but I'll show you how we can use this to look at how the land use varies around it and various bookmarks that they can go to up towards the source and things like that. We can also look at the geology of it, which is a very interesting one because the geology changes considerably as the Colin River moves down through the Colin Glen. Any of you who do your fieldwork here will know this. But what I want to do is to show you how this can be used to present the data that you've collected. We're not going to be going out with our Year 11s this year, I would imagine, to carry out fieldwork because of social distancing, but our Year 11s last year used Survey 123 to collect the data, and I've managed to get some of that data on here for you. So if I zoom in a little bit to the section of the Colin River that we investigate, we start here up in the source and then we come down in here into the Colin Glen, and I can turn on this fieldwork data which can show you where that data is located. So you can see the survey points that we went to up near the source, and you can see how this is used as a presentational tool. Now in the exam, of course, we've got to draw the graph, but I think this is an equally valid way of presenting it, and then if anything it actually spatially contextualizes it even better for them. But because this is GIS, you can have a lot of extra information in with the circles that are presented here, because I've got not only the depth, which I think is the one that's presenting there, but we've got the width, you've got the average depth, you've got the description here and the velocity, and for each one of these points we have got this information. And what they can do is to go and collect that information there and interrogate it and go and have a look at it and see what is presented. And it's also, we like to get them to use the photograph function here, take a photograph supposedly of the river itself, but of course they like to take photographs of themselves posing in it, don't they? So that is presenting the data here, and it is, to me, a very, very legitimate way of presenting it. You can use this alongside a graph, but that's an incredible data presentation tool. That's not the only way you can present this data. Let me show you what else you can do with it. I showed you at the start of this presentation how ArcGIS can represent information not just on 2D maps but on 3D interactive landscapes, and that you can take the data that you've collected through Survey 123 and you can put it into this. It's called a scene, and you can really contextualize the data into the particular landscape itself. When we collected this data with our students, we brought them back in again to class, and of course we've got to train them how to do the hand-drawn graphs for the exam. And no matter how many times you say to them, I'm sure you have the same experience as well, that along the bottom you're not just putting survey sites, you're putting distance from the source. So I told them that and then let them have a go to see how many in the class would actually get this right. Most of them did, but there was a small but sizable minority that had the gap between all of the survey points exactly the same. They didn't put distance from the source, they just did survey sites. Now what that shows me is that as they're sitting in my classroom, they have actually managed to disconnect the fact that the survey sites weren't equidistant, that there were different distances between them. They've managed to, in other words, decontextualize the data from the landscape. It just becomes a table of numbers, and I'm plotting this on a graph in the same way that I would plot a graph in science after my experiment. But what if we present it like this? I still remember the first time that I showed this to my students when we went from the 2D map to this one. I had literal gasps around the classroom as they realized what they were about to see, and I demoed them this. So there's the source, and then we can look downstream with this, and then we can spin around and go down to some of the other survey points and look back up at where we've come from. This is survey point 2, and we can get a real sense of the distance, and there is the Colin Glen that we've been walking down through. Let's go down to the next one, and this so contextualizes this in space, and we remember that the Colin River is surrounded by urban areas, and of course, this being GIS, any one of those contains all of the information that you've collected, including those wonderful photographs with the students posing in them. But this is absolutely turning space into place, and it's bringing to life this data in a way that otherwise just simply would not be possible. And for them to interrogate this, to move around, to sweep around and crash into the hillside, they can really just get a sense of this particular river in this particular location, and they can see through this what they would not otherwise be able to see. And what of the decision-making exercise? In the exam, obviously this is a paper-based exercise, but is there any scope for using GIS for this? Yes, there is. Now, to me, the DME is a wonderful addition to the study of geography. To me, it represents the pinnacle of all of these years of geographical study, of all of the knowledge that the pupils have built up, and all of their evaluative ability as we have looked at examples of case studies of pros and cons and making decisions. Everything is wrapped up in this and what this represents, to throw them into a brand new context that they've never seen before, and for them to be able to thrive in that context because of the skills they've picked up as geographers. So what I'm going to show you now is an exercise that we put together for our Year 13s in June when they came back after doing their AS exams in preparation for this transition from AS to A2, and taking a look at how we can do this with our decision-making exercise. So they do this based on this Google site, just gathers everything together for them, and we first of all get them to think back a little bit to their GCSE, get them to take a look at some of the coastal management strategies that they would do there. And then we introduced to them the bit that's new for A2 and for A-level, which is the shoreline management plans. And we talked to them about the shoreline management plan being this framework for decision making. Now, obviously, they've got to study this as part of the course itself, so it's a good investment into that. And we give them this knowledge schema so that they can get to grips with the various elements that are in the shoreline management plan. In particular, things like cost-benefit analysis, economic impact assessment, running through the different types of approaches that can be taken from the shoreline management plan decision-making point of view, the methods and the impacts, all sorts of things like this. We give them an introduction to that, tell them a lot about it, and then we take them into the bit where they have got to make their decision. And this is where this GIS map helps us to do what we would be doing in our decision-making exercise. So the first thing that we'll do is to set the context of North Norfolk in the national context. As you know, that's an important part of many decision-making exercises. So into the map. These are the various layers they're going to be using, and we start off with this national context. And the question that we get them to look at here is to describe the variations in erosion around the whole of the UK and compare North Norfolk with that. Are the erosion rates constant around the UK? Do they vary? Now, of course, you can look here at the legend at any stage. These are proportional lines, but this being GIS, of course, you can click on them. And my goodness, look at the wealth of information here. You have got different percentage confidence levels in the medium term or in the short term, and wealth of data. They do need guided through this, but you can get them to pick out certain things from this. Say, what is the long term? What is the 50% chance of erosion taking place in the long term here? 104 meters at that location, and they can go around the various locations and find all of this information out, lots and lots of them. And then of course they can go into North Norfolk and compare that with the erosion rate around about the UK, set something in the national context. Then we can link that through to the geology. It gives an opportunity for you to talk about some of the isostatic and eustatic changes in sea level that will be occurring, and particularly down here in the southeast of England, where the area wasn't glaciated during the last period of heightened glaciation, and you get an awful lot of deposition occurring here. So if you click on here, you see that this is clay, gravel, sand and silt. Over here we've got some chalk, and then you move over here, the geology gets very much more complicated. But in North Norfolk, particularly in the northeastern part of Norfolk, you have got this this gravel, sand and clay. Now, when we were introducing the shoreline management plans to them as part of our presentation, we showed them photographs like this, where you can absolutely see this. The cliffs that you've got here are very different from the cliffs that they may be used to in, say, the Causeway Coast of Northern Ireland, made from the basalt, and not very susceptible to erosion in comparison to these cliffs here. But to give them that sense of this in terms of the setting for North Norfolk. Then we can move on to have a look at the sites of special scientific interest. Because of the shoreline management plan, the environmental impact assessment needs to take a look at the impacts on the local ecology. So we can come into this map. I'll just turn that one off, and I will turn on the sites of special scientific interest. They can manipulate these layers and they can move around the map, and what we discover is that there are large portions of the coastline here that are protected by SSSIs. Which means that there is a legal framework of protection for the ecology in these areas and these locations. Any management that takes place here will need to take that into consideration and bear that in mind. And again, they can explore the whole of the map and they can see where those areas are. Moving on down, then we can get them to take a look at a couple of particular examples of where erosion is taking place, and again the bookmarks can be helpful for this one. So Haysborough, everybody knows Haysborough, but we've got an interesting thing here. It's sitting underneath an historic map. If I'll just toggle this off and on, and you'll see this. Now I have changed the transparency of that. You can do this with the map as well. Set the transparency up to about 75%. If I take this all the way down here, you'll see that will be all you'll see. You can't see both of them, but to change the transparency like that allows me to see both the map, the present day map, and the old map as well. And I can then come in and explore this, get the students to measure the rates of erosion. There's your good old measure tool again, the sense of scale. You can take this in. They can do various measurements here of how much erosion is taking place from that time period, 1885 to 1903, to the present day. We get them to do that also in Sidestrand, but the interesting thing in Sidestrand is that we need to get in to consider the cultural heritage. That is something as well that needs to be part of the shoreline management plan, how you recognise the impacts on the heritage here. And in this particular example, we have this old church. In fact, if you see, I'll show you this. Oh, sorry, that's the wrong link. Let me take you through to this one here. See this old church, and there's a photograph of it. But that old church used to be, if I go to this bookmark for you, Side Strand, there's the old church there. So they actually had to relocate that old church and move it inland. So what I can get them to do then is to take a look at where that new church is, turn on the erosion rate layer and ask the question with 95% confidence, how long will it take until that poor church needs relocated again? They can really delve into this map and really understand these things much, much better. Then you can step out and take a look at things like land use. So if we zoom back out again to see the whole of North Norfolk, I can turn on my land use layer. And I can see that most of this area here is, if we look at this non-irrigated arable land, there are some towns and small settlements, but it is not a highly urbanized area. We can also then look at the population density as well, how many people are living here. If we turn that layer off, we can turn the legend on, and we can see a very similar pattern here. You do have some high density areas in places like Cromer, but most of the rest of it is very low or down towards the lowest. So you can get a sense here of that economic impact assessment, the cost benefit analysis here, of looking at the value of the land being protected versus the costs of building and maintaining the defences. They can really get a sense of that as well. Which then brings us into making the decision. That's all about setting the context of this. How do they go and make the decision? Well, there's an area that we've given them here of Trimingham. I'm going to turn this population density map back off again. And I can put this box in here to show them the area that I want them to look at. And I can take them through here some exercises with this. Now, I've given them a budget here of £25 million, and they need to make policy decisions for this section of the coast. So what they need to do here is basically to take the overall thing that we've been looking at and really to pin it in specific detail to this area. Look at the erosion risk. So we can turn on the geology. As we know, it's that sand and clay and that kind of thing. But then I can get them actually to do some data collection here. So I can get them to sample erosion rates along this section of coast and get them to think about the technique that they're going to be using and what intervals. We'll get them to select 6 sites here. So they can go in here and use the measure tool again. Go from here to here, and we see it's about 3 kilometers. So every 500 meters or so, you're going to be doing the sample. So I need to turn on the erosion risk here again. Here we have it. Remember, each one of these places is clickable, and we can get some information about what the erosion rates are at each of those. So I need to go 500 meters. How do I do that? Here's my measure tool. I come down here to approximately 500 meters. So that's where I'm collecting my data, and I can click on there and I can get my erosion rates and then go through and I can complete this table. And that allows me then to do what we would do within our decision making exercise, to choose a suitable graphing technique and to produce a graph in this table. Of course, this being GIS, we don't want them to hand draw it, because who does that in the real world these days? We want them to use the spreadsheet to do so, and then they can experiment with the presentation of that. So they can go through the SSSIs, the historic buildings, about the church, all of that they've looked at specifically in here. And in light of that, they then need to make their policy decision. What are they going to do? What do they get to choose from? It's those here. So which one are they going to decide? And having decided that, they then have to choose the methods they're going to conduct. Remember, we gave them a budget of 25 million, and there is a rough indication of some of the costs of the various methods that they want to use. I can then get them to mark this on the map. This is relatively easy to do. Just come in here and add map notes, which allows me to add in lines, shapes, push pins, can put text in with those, all sorts of things like this, able to add those on. That green box there is a map note, so you can add those in like that as well. And they can annotate onto the map in order to do that. And then, of course, this being a decision-making exercise, they need to justify their decision based on the greater overall benefits of the decision that they're making. Well, no, just a whistle-stop tour of that. There's about 3 weeks worth of work in that. Obviously, we do that in June, so we do have the time for this. But during these times of lockdown, the students are looking at and working on this at home. So we've actually produced a whole series of resources that will help them to do this outside of class. So in future, if we're doing this and we don't have time in class, this could be a project that could be running along at home. Something that they could be really investigating. But think for a moment of the powerful geography that they have just investigated there. Think of the range of information. Think of all of the data that they have explored. Think of the different scales, starting from that scale of the whole of England right down to the scale of a 3-kilometre section there and the regional scale in between. Think of the range of factors and think of how much geography they have done. Think of how that geography represents the way in which geography is done in the real world. Wouldn't it be great to think that at some stage our assessment for geography, for the decision-making exercise, will no longer be a paper-based exercise, but something like this? Something that is really replicates the way this happens in the real world, to give our students not only a sense of the geography that they may go into in their careers, but actually a sense as they're doing it, of the geography they're studying now. I said at the start, why do we do this? Why would we take the time to reproduce these resources, to upskill the students? Why? Because the GIS helps us to do the geography better. There are many other benefits, but if that wasn't there, you could probably say that we can't justify it. But that sits right at the heart of this, the ability to think powerfully and to think geographically about these areas and to empower the students not just to do geography, but to become geographers. Well, I hope that you've enjoyed that very brief overview and introduction to just some of the things that we're doing with GIS with our geography students in Lurgan College. We could talk about the benefits of GIS, the fun and the engagement level with it, how it opens up their eyes to the future careers prospects through geography, all of which are important. But at the heart of this, the reason why we do it is because it helps them to do their geography better. As the title says here, it's unleashing their geographical vision. It's letting them see things about the world that without the GIS they would really struggle to see otherwise. And that's why I'm using it, and that's why it's important. Now, I'm very interested in exploring some live webinars for geography teachers to take this a little bit further and find out how you might be or begin to use GIS within your teaching. If that's something that you're interested in, please do get in touch with me. You'll see my Twitter address there at LCGeography. It's the easiest way to get in touch with me. Do reach out, get in touch, and let me know if that would be something you would be interested in, because I certainly would be very keen to help. In the meantime, thank you very much for your time today. I hope you've enjoyed it, and I'll be around in the panel discussion later on. So if you have any questions, just fire them at me and I'll do my best to help them. Thanks very much.